Hi, this is Jason, and welcome to our hands-on video covering EC2, the Elastic Compute Cloud. I'm already logged into the AWS dashboard, and what I want to do is go to the EC2 service. So I'll click on one of the EC2 links, or I'll search for EC2 in the dashboard. Now, if you've been to the EC2 dashboard before, it might default and be displaying the current instances that are running in your region. The other possibility is that you might see this EC2 dashboard sort of homepage where it gives you a list of all the different resources that have been created in the region. The first thing that we're going to do is we're going to go to the instances area. By the way, there are tons and tons of different features that are available in EC2. Things like load balancers and auto scaling groups and all kinds of other stuff that we're going to look at in future classes. Today, we're really just focused on EC2 instances and things like Amazon machine images. Okay, let's click on instances in the left-hand navigation, and this will show us any instances that are currently running in the region, which in my case, I don't have any instances running currently. EC2 instances are virtual machines. These are virtual machines which run on physical hosts that are maintained and managed by AWS. And what we're going to do is we're going to go ahead and create an EC2 instance. I do that by clicking on the Launch Instances button. And here, the first thing I have to do is select an Amazon machine image, an AMI. An AMI describes the operating system, the applications in a certain configuration that they're all baked into what we call an image. You can think of this as being sort of like a template that we can apply to a new instance. I could create 10 different EC2 instances all using the same AMI, and that would guarantee that all of those instances look the same when they start up. All of those instances would have the same operating system, have the same software installed on them. So we always launch an EC2 instance using some sort of base image, some sort of Amazon machine image. And many of these images are curated by AWS, meaning that AWS manages the creation of these images. But it's also possible for us to create our own images. It's something that we do all the time. So if you're working in an organization, it's likely that you would create your own set of images with your desired software and configuration baked into the image. You can also acquire images from an online marketplace. There's an AWS marketplace where third-party vendors will create images and allow you to essentially rent those images on a monthly basis, and that's an opportunity to easily launch EC2 instances that might contain commercial software that you would like to use in your organization. There's a list here of different curated images we can pick from, everything from Amazon Linux 2, which is what we use primarily in this class. You can select from Mac OS and Red Hat and Ubuntu. These Red Hat and Ubuntu are different types of Linux distributions. Of course, there are all kinds of different Microsoft Windows servers that you can launch as well. A wide variety of different images. Let's go ahead and select the first one, Amazon Linux 2 image. We've selected that image, and now we have to choose an instance type. And as I talked about in the lecture, there are a wide variety of different instance types that are available to us, and each type of instance will provide a different set of computing characteristics. It's kind of like picking the size of the server that you want to run your software on. You might have small instance types that give you a small amount of CPU and memory and maybe relatively slow storage or networking. And then there are also, much more powerful instance types that allow you to run large database workloads, or maybe like really memory intensive machine learning applications. The idea here is that you want to select an instance type that aligns with the type of software workload that you want to run on the EC2 instance. In this case, we're going to stick with the T2 micro instance size. This is also free tier eligible, meaning that if you're a new customer, you can actually launch a T2 micro instance and it won't cost you any money for up to a year. By the way, you can only run really one of those. If you run multiple T2 instances, then essentially you're consuming more of that 1 year time allocation. So you're going to kind of burn through the time faster. But for the most part in this class, when we use T2 micro instances, there's really no cost to students, which is great because we can use it as a learning tool. We've selected T2 micro. Now we're going to click on the next configure instance details button. And here we have the opportunity to configure a number of different attributes for our EC2 instance. Starting with the number of instances, which is defaulted to 1. If I wanted to create 10 EC2 instances that all have very similar configuration, I could change this number to 10 and launch 10 EC2 instances all at once. It's a easy way to launch a whole fleet of servers very quickly. Under purchasing option, I have the option to request spot instances. If I check that, then it'll give me the current spot price and allow me to bid on a price, or at least bid on a maximum price. Essentially what this is AWS has what they call a spot deployment model, meaning that at any given time, AWS has all of this compute capacity, which isn't being used by anybody. This compute capacity is just sitting there waiting for somebody to purchase it. And instead of just letting that compute capacity sit there unused, AWS will make it available to customers at a significantly discounted rate if they request it as a spot instance. And a spot instance means that you're renting that computing instance from AWS, but AWS may take the capacity back away from you at any time and terminate that instance. And so this is a great way to get really cheap, inexpensive compute capacity that you might only need to utilize for a short period of time. We're just going to launch a normal instance, so we'll uncheck that request spot instances option. We have a few network settings that we can configure. We have the network location, the VPC, which is the virtual private cloud. We'll talk about that in a future class. This is the network and the subnet are basically defining where this EC2 instance is going to be deployed within your virtual cloud network, within your virtual cloud environment. And we have an entire class where we talk about VPCs and subnets and networking, because it's really important in terms of understanding EC2 instances and how to wire things up properly from a communication perspective. we have the option to select a placement group. A placement group is a way of placing EC2 instances close together think of it, placing them close together from a physical standpoint. If I want to maximize the network communications and performance between multiple EC2 instances that might be members of something like a cluster, maybe they're part of like a Hadoop cluster or some sort of like data storage cluster, I might try to configure those EC2 instances so they're all part of the same placement group. And what AWS will do is it will try to physically co-locate those EC2 instances close together so that all the network communications between those instances are optimized. We have the ability to look at capacity reservations, which that's more of an advanced topic that we're not going to address in this class, or joining a domain directory. That's something if you're launching something like a Microsoft Windows server, you can configure the server to join an Active Directory. Again, something that we're not going to use in this class, but it's commonly used in a corporate environment. IAM role allows us to attach a role to an EC2 instance. Remember, a role is associated with one or more policies and which define a set of permissions. And so when we create a role, oftentimes we think of a role being something that's applied to a user. When a user accesses AWS, they have a certain set of access permissions that allow them to do different things. But we can also apply roles to EC2 instances, meaning that when we launch this EC2 instance, the EC2 instance has a role attached to it. Any software application that's running on that EC2 instance could potentially access other AWS resources. For example, you might have a web application that needs to communicate with something like a DynamoDB database table, and it could be granted the permission to communicate with that table through a role that's attached to a server. And we've already used this a few times before. We have a role called SSM access that we've generally been applying to our roles. And this SSM access role basically enables us to use a service called AWS Session Manager to log into that server using a web-based terminal session. We can modify the shutdown behavior of the instance. This is basically saying, well, what happens if you shut down the instance? By default, it will stop the instance, but you could also tell it to terminate the instance. So if somebody shut down the instance, you could instead of just shutting it down, it would actually go ahead and delete or terminate the instance. We can enable termination protection on an instance by checking this box. And what that means is that there's another layer of protection that's enabled that will prevent somebody from accidentally terminating this instance. So if you enable termination protection on the EC2 instance and another team member accessed this web console and clicked on the EC2 instance, maybe mistakenly, and they tried to terminate it, then they would be prevented from terminating the instance because termination protection is enabled. So oftentimes we'll do that for really important EC2 instances. Maybe if we have an EC2 instance that's running something like a database server, for example, that's a mission critical kind of workload, we will enable termination protection for that instance to prevent somebody from accidentally deleting the instance. And that might sound kind of strange, but you'd be surprised. If you're working in an environment where there's literally thousands of EC2 instances, then it can be, easy to get for somebody to get confused and accidentally try to delete the wrong EC2 instance. We can modify the tenancy model of the instance. By default, the instance is deployed into a shared environment, meaning that AWS is going to create a virtual machine, and that virtual machine is going to be deployed onto a physical server where virtual machines are running potentially from other customers. So your virtual machine is sharing the same physical server as virtual machines from other customers. There are some cases where that is, companies won't do that for compliance reasons. There might be regulatory reasons that are sort of preventing them from leveraging a shared deployment model. These tend to be fairly rare. But if that were the case, then you could switch it to a dedicated model and run the instance on a physically dedicated server where your EC2 instances, your virtual machines, are the only ones running on that physical server. You could also launch the instance as a dedicated host, meaning that essentially it's almost like you're just simply deploying one virtual machine to that server. And so you wouldn't be running multiple EC2 instances on a physical host. You'd only be running that one workload on a physical host. So a number of different options there. Of course, you pay extra for these options. These dedicated instances can be quite expensive, and so that's one of the reasons I feel like it's relatively rare these days to see organizations deploying their workloads to dedicated infrastructure. We're going to skip down here to the advanced details section. There's a number of options here that there's more advanced options that we're not going to cover in the class. By the way, for any option, you can always kind of roll over this little eye icon to get more information about what that option provides. But many of these other options are things that are fairly uncommon. You wouldn't be making changes to them very much. I wanted to point out this last option on the page, however, the user data option. And this one's important because we'll use this in the class. User data allows us to specify a shell script that will be executed at launch time. So the very first time that this EC2 instance launches, the EC2 instance will can run a shell script. So I could type in a shell script here that says something like yum update, and it will perform an update, a yum update, the very first time the instance launches. This is very common. It's almost always the case when we launch an EC2 instance that we define some sort of bootstrapping script to help us launch the instance or configure it at deployment time. For now, we'll just leave that blank. But as I mentioned, we will use it in some exercises during this class. I'll click on the next Add Storage button, and this allows me to modify the elastic block storage that is associated with the EC2 instance. Remember, elastic block storage is is like a hard drive. You could think of it as like the virtual equivalent of a hard drive. And by default, our EC2 instance has an 8 gig hard drive. I could change that, let's say, to 10 gigs, or I could change it to 100 gigs, or even 1,000 gigs. And I can also select the volume type. There are different types of storage that are available to us. We're using the general purpose SSD storage GP2, which is fast storage and perfect for this example. Within the last year, AWS, and this is as of 2021, AWS released GP3 storage, which is even more flexible than GP2, and it turns out slightly lower cost as well. If I'm running more intensive workloads, then I might want to use provisioned IOPS storage, or IO1 and IO2 storage. These allow me to provision very high IO rates and IO access, meaning that I can perform a extremely high volume of disk transactions. Why would you want to use this? Well, I mentioned like using this for intensive workloads. A perfect example would be something like a database server. Database servers are very IO intensive, and so it's very likely that I would choose a provisioned IOPS option for something like a database server. And there's always the old magnetic storage. So the magnetic storage is literally the old spinning hard drives that many of us still use maybe in our home computers, although our laptops and computers are mostly moving towards solid state drives. You can still attach old magnetic storage as well. And this, of course, is not nearly as fast as SSD. However, it is a lot cheaper. And so if I needed to create an EC2 instance that was going to store a lot of data, and I didn't really care about the performance aspects of the hard drive access, maybe the data wouldn't be accessed very frequently, then I would choose magnetic storage because that would be my cheapest option. We'll just leave this at GP2. And of course, I only have one storage volume that's attached to the system. I could add another one. I could add several more storage volumes. This is also very common. It's very common to partition the storage on a server into multiple volumes, into multiple devices. This is something that we do all the time, and we can do that using this interface. I'm going to go ahead and delete that one. I'm just going to keep things simple for you and leave it at one volume. I'm going to click the Next Add Tags button. And here we can add metadata tags. I've talked about this already a few times, where this is just a set of key values that we can associate with an AWS resource. And these key values can be whatever we want them to be. So maybe we have a project, and the project is called Fido, and we want to tag this EC2 instance with the project code name so that we can easily run a report later to show us all of the project Fido resources that we're using in our AWS account. I'm going to click the Next Configure Security Group. And here's where I configure the security group that is associated with the EC2 instance. And this is just incredibly important, right? Because the security group represents the sort of layer of network security. It's like a firewall system that envelops our EC2 instance. The security group determines what data can be communicated in and out of our EC2 instance. It's really important to get this right and to create security group rules that align with our business requirements. In this case, let's create a new security group. You can see that AWS provides some default values, but generally we don't want to use the default values. We're going to create a security group with a name. Let's call it, we'll call it just the web servers. Let's call it dev web servers group, dev-web servers. And for the description, we'll just say that this is for the development web servers. This is the development web servers security group. And now we can define some rules. Now these rules are defining incoming rules, or what we call ingress rules. And by default, AWS has a rule allowing SSH access, which is coming on port 22 from anywhere. Anywhere is denoted by this, what we call the CEDAR range, 0.0.0.0/0. So that represents the entire internet. The way I would read this security group rule currently, it would be that incoming SSH access is allowed from anywhere in the world to this EC2 instance, which is actually a really undesirable security group rule. And in fact, AWS provides us with a warning saying, like, you know, that they recommend tightening that security group rule. And actually, we don't need this SSH access at all, because instead of using SSH to access our servers, secure shell from like a client, a secure shell client or terminal client running on our workstation, instead of using that, we are using AWS Session Manager, which is much more secure. I'm going to go ahead and delete this rule because we don't want to use that. However, let's add a new rule, and I want to add a rule that is going to allow web traffic. Web traffic, the standard port for web traffic is port 80. Encrypted web traffic is port 443. So when you do HTTPS in your web URL, that's using the SSL TLS port, which is port 443, at least the standard port is. So let's create rules for both of them. For the type, I'm going to select the, let's see, we're going to select HTTP as the type. And when I select the HTTP protocol, it's automatically populated the port number for me, which is nice. It's port 80. And we're going to allow that from anywhere in the world. So 0.0.0.0/0. You notice that there's actually two terms here. The first one I just mentioned, and then after the comma, you see this strange looking string, which is 2 colons and a /0. This is actually the IP6 version of the network subnet, which represents the entire internet. This is the standard IP4 version. This is IP6. You don't have to really worry about that in this class. I just wanted you to, didn't want you to be surprised if you saw this and it looked kind of strange. That actually is a valid configuration string to have in there. For the description, it's always a good idea to describe what these rules are doing. And I'm going to just say website access from anywhere. Let's add another rule. In this case, it's going to be HTTPS, which is port 443. Again, allowing access from anywhere on the internet. I'm going to say secure website access from anywhere for that rule. Those rules look fine. So we're allowing port 80 traffic, port 443 traffic, both encrypted website traffic and unencrypted website traffic into our EC2 instance. I'm going to click the review and launch button. And now I have the opportunity to review all the different configuration settings that I have enabled. Some of them are kind of hidden by these drop downs that I can expand. All these look good. I'm going to go ahead and click the launch button. And here I'm asked for an encrypted key pair. This is only when you're using SSH. And because we're not using SSH to access the server, I'm going to say proceed without creating a key pair. I'm going to acknowledge that I want to do that. I say launch instances, and AWS will go ahead and launch the instance for me. I'm going to click on the View Instances button, and this will take me back to the dashboard and show me the list of instances in my account. You can see here's a new instance, and it's in a pending state, so it's being launched. I can scroll over and see some of the additional information about the instance. We'll take a look at this more in a bit. Every instance has an instance ID, this long alphanumeric string here. Every single instance within AWS has its own unique instance ID. And so this is sort of like under the hood how AWS references our instances. You see that there's no name for our instance, which is actually, this is a good opportunity to kind of look and see what we can do about that. If I select the instance and click on actions, there are a number of different things I can do with an instance. I can change some of the instance settings. So even after I have launched an instance, there are potentially settings that I can change for the instance. For example, if I had enabled that termination protection, I could go into this area here and disable it. I can manage the tags, and let me go ahead and do that. Remember, we had created a single tag called project with a value of Fido. I'm going to add another tag, and I'm going to just call the tag name. This is kind of a special tag. I'm going to call the key name, and the value is going to be, I'm just going to call it web1. And we'll go ahead and save that. And notice now in the name column, my instance has a name called web1. EC2 is basically taking that key I created, that name key, and it's using that to denote the name of the instance in this dashboard, which is kind of handy because it's hard to remember the instance IDs for instances, and it's much easier if you can name them something that is more familiar to you. I'll click on the instance ID here, and here I can see all kinds of configuration information about my instance. I can see the VPC, the subnet that was launched into. Again, this is all networking kind of related stuff. I can see the public IP address. This is oftentimes very important for us, especially in this class. This is every single EC2 instance has a private IP address. This is a private non-routable IP address, which is only accessible within our cloud environment. It's not accessible from the internet. So this is like an internal IP address, a private IP address. Some of our EC2 instances, as we'll learn, can also have public IP addresses, meaning that this EC2 instance is accessible, potentially accessible from the internet, especially if we have a security group in place which allows incoming access from the internet. If I wanted to access this server from the internet, then I would reference it by this particular IP address. It shows me the instance type, which is our T2 micro. I've got an IAM role associated with it, the SSM access role. And down here, I can look at all kinds of different details, like when the instance was launched. I can see the AMI that was used. Every single AMI has its own ID, its own identifier. And I can see the name of that AMI, which is Amazon Linux 2. I can tell it was Amazon Linux 2 just by this naming format here at the beginning of the AMI name. All kinds of information. If I can, there are several tabs here. So like the security tab, I can click on, and this shows me the inbound rules associated with this instance. So you can see port 80 and port 443 access is allowed incoming from anywhere in the internet. Also, it shows me the outbound rules. And by default, everything is allowed out from the EC2 instance. So all protocols, all ports are allowed, all communications are allowed out from that instance to anywhere in the world. Now, in our organizations, when we launch EC2 instances, generally we will define outbound rules as well, or what we call egress security group rules. I don't do that in this class because it's oftentimes very confusing for students that don't have it's sort of a networking or security background. So I try to keep things a little bit simpler by focusing just on the inbound rules. But I wanted just to note that you can also define outbound rules, and typically we will try to do that in a corporate environment. I can look at some of the networking stuff down here as well in the networking tab. Some of this, of course, is duplicated above. We can look at storage information and see the different volumes that are attached to our EC2 instance. Oh, one thing I could have done, I didn't in this case, is I could have enabled this as an encrypted volume, which is very common. Just like we can encrypt data at rest in something like S3, we can also create encrypted hard drives or encrypted EBS volumes for our EC2 instances so that our data is encrypted at rest as well when it's stored on an EC2 instance. I can look at monitoring details for the instance using CloudWatch, which is a service we'll learn more about. Right now, there really isn't much here. It's not too exciting because we just launched the instance. If you have an instance that's running for a couple hours, then I encourage you to go back and check out monitoring. And what you'll be able to see is that AWS is collecting a bunch of metrics from these instances over time, and so it can show you how much CPU utilization and how much disk utilization and so on associated with that instance. So you can see like some of the the performance characteristics of that instance over time. This is our EC2 instance. Now, if I want to connect to this, I can select the instance and click on the connect button. And of course, we're going to connect using Session Manager. So that's already selected. And I click on connect. And this is going to connect me then to the terminal on the EC2 instance. And at this point, then I can run all kinds of commands. I can get sudo access and super user access and run whatever command I would like on this particular system. When I access the system, I'm accessing it as a special user called the SSM-user account. So that's who I am at the moment when I log in using Session Manager. And one thing I just wanted to point out, actually a couple things that are really interesting about these instances. I mentioned something in the lecture about instance metadata. Instance metadata is a really cool feature where AWS creates this internal API endpoint that we can access from within the running server environment. And it allows the EC2 instance to programmatically query information about itself, which might sound a little bit strange, but when you think about it, we're connected inside of a virtual machine, inside of a server environment. The virtual machine has really no idea where it's running. It has no context of like, what does the outside world look like? What does its host look like? And so on. It has no concept of, this Linux server has no concept of AWS and the AWS environment that it's running in. But it can get information about its running environment by querying this special API endpoint. So if I use the curl command, curl is a terminal-based web browser, essentially. If I use the curl command, I can hit a special endpoint, which is at 169.254.169.254. And if I query that endpoint to get some metadata information, then it responds back with this list of API endpoints that I can hit to get different information about the EC2 instance and the environment that it's in. So for example, if I hit that endpoint again and then type in public IPv4, then it responds back with the actual IP, the public IP address that is associated with the EC2 instance, which is pretty cool. And so there's like tons of different information that the instance can query about itself using this instance metadata endpoint. And this is something that we use all the time. It's a very, very useful feature. One of the other things that we can do when we're on an instance is, especially an Amazon Linux instance, is we can use the AWS CLI. The AWS CLI is a command line tool that allows us to interact with the AWS API directly. And so I remember, I think I told you in a previous video that everything that we do using the AWS Web Console, the web interface, we can also do all the same things programmatically. We can do them using this sort of tool, the AWS CLI tool. So I can use the AWS CLI command in something like a Linux shell script, and I can use it to do most anything that I really want to do, as long as the privileges are available. Now, if I run this AWS command, and if I try to access things in my environment, my cloud environment, the AWS tool is going to look for a set of credentials. And the first place it's going to look at is going to look at the credentials that are provided by the role, the IAM role that's attached to the EC2 instance. And if that IAM role gives the proper access permissions, then the AWS CLI tool will be able to perform those same actions. However, if the role doesn't provide access that the AWS CLI tool needs, then I'd have to configure the AWS CLI directly and provide it with a programmatic a set of API keys. Remember the API key and the secret key that we can associate with user accounts. I would need to provide the AWS CLI tool with a set of credentials that it could use to access the AWS API. Let's go ahead and log out here of the shell. So I'm just going to say exit. I could also just click on terminate, and that session has now been terminated. I'm going to go ahead and shut down this instance, because what I'd like to do is create an AMI based on this image. And this is a pretty common pattern. What we will do oftentimes is we'll launch an EC2 instance. We will install our software and configuration on it, and then we want to use that instance as a template to create new instances in the future. So we want to take that instance, the way it's currently configured, and turn it into an Amazon machine image. I'm going to do that. The first thing I'm going to do is I'm going to stop the instance, which is always a good idea. It's called quiescing the instance. It's basically shutting it down so that there are no changes made to that instance while we are converting it into an image. So we've gone ahead and stopped that image. And next we're going to go into the actions, image, and templates, and we're going to go ahead and create an image. We're going to create an image. We're going to give it an image name. So we'll just call it, we'll call it my web server image. We can give it a description, and we'll just call it a web server. Very simple. And it's asking us some information about volumes that we want to include. We're just going to leave that at the default. We could specify a tag for our image. We'll just leave that for now. And we're going to click on the Create Image button. And what's happening now is it's saying it's successfully created the AMI. So we'll click on this link, and it'll actually, or we can just go over to the left-hand nav actually, and under the images section, we can click on the AMIs link. And here you can see it's creating a new image called my web server image. I'll select that, and you can see that the status of that image is pending. It can take a while to create an image, and it all depends on how much data is stored on that image. For example, I've seen images take like 5-10 minutes to create that are fairly small. On the other hand, I've seen images that store terabytes of data, and it's taken hours to create an AMI based off of those EC2 instances. So it really depends on how much data is stored on that EC2 instance when it's being converted to an image. I'm going to pause it here, and I'll return once that image has finished creating the recording. And that AMI creation took about 5 minutes, so it was a relatively quick process. I'm going to go ahead and click on, let's see, I'm going to click on the instances link. on the left-hand side and go back to my instance. That's pretty much, all the basic information I wanted to show you today about EC2. The last thing I want to do is just go ahead and delete this EC2 instance. I'm going to click on the Web1 instance, and I am going to change the instance state to terminate, and that will blow away. It will permanently delete my EC2 instance. And we generally tried to delete our instances in this class, and that's actually a fairly common pattern as well, and we'll learn why that's the case later in the course. Well, I hope you enjoyed this video today, this hands-on session, and I look forward to the next hands-on session with you.